This is the first lecture of week 6, and we're going to cover the hypothesis test for one coefficient. Here's an outline of what we're going to cover this week and the relevant chapters. So the first lecture will cover the hypothesis test and confidence intervals for one coefficient. The second lecture will cover the joint hypothesis test on multiple coefficients. And then the third lecture will cover other types of hypothesis testing, including multiple coefficients. And then the last lecture will cover variables of interest, control variables, and how to decide which variables to include. So going back to our original policy question of looking at the relationship between test score and student-teacher ratio, here's the data output when you regress test score on student-teacher ratio and percentage of English learners. We get these coefficients as well as the standard error, and we're going to write these standard errors in underneath the coefficient in parentheses. As you can see, when you include both the student-teacher ratio as well as the percentage of English learner in the model, we said previously that the coefficient for STR measures the effect of how much test score changes when STR changes, holding the percentage of English learner constant. You'll also notice that when you include percentage of English learner, the coefficient for STR actually decreases by 1/2. So this indicates that the previous simple linear regression model suffered from omitted variable bias. So since our coefficient for STR decreased so much, now we want to test if STR has any effect on test score. So in order to test this hypothesis, we need to set up a null and alternative hypothesis. So in this case, null hypothesis would be that the coefficient for STR is equal to 0, and alternative would be coefficient for STR is not equal to 0. So hypothesis testing and confidence interval for a single coefficient and multiple linear regression model is basically the same thing as in simple linear regression model. So in order to do the hypothesis test, you need to calculate the test statistics. And the formula of the test statistics is the same as simple linear regression model. And the formula for calculating confidence interval is also the same as simple linear regression model. This applies for regardless of which coefficient you want to test. So even if you're testing for beta 2 or beta 3, the formula remains the same. So Stata makes it very easy to calculate confidence interval as well as carry out the hypothesis test. So here's an output of regressing test score on student-teacher ratio and percentage of English learners. And Stata outputs give you all of the numbers that you need to calculate confidence interval. So in order to calculate confidence interval, we need to calculate the beta hat 1, which is given in the Stata output, plus minus the critical value and the standard error, which is also given in the standard error of the Stata output. The confidence interval is also given in the Stata output as well, so you don't have to do this calculation. In order to do the test hypothesis testing, you need to calculate the test statistics, which is the coefficient divided by the standard error. And this is also given in the Stata output. And in this case, because the absolute value of the test statistics is greater than 1.96, which is our 5% significance level critical value, so we reject the null hypothesis. Again, going back to our previous lecture, we can also use a p-value in this case, and in this case, p-value is 0.01, which is less than 5%. So we also reject the null of beta 1 being equal to 0 and conclude that this coefficient is statistically significant.